Hello, my great students going through group theory. How are you doing today? I hope you're doing well, and I wish that you are doing well. Okay, so we were doing topics on group theory. We have covered multiple topics on group theory, given multiple mathematical examples. Okay, topics like abelian group, coset, then multiplication modulo, then normal groups, normal subgroup, okay, simple group. Okay, there are many topics we discussed. All right, many things we went through in this group theory part, and there are many more things that we are also going to go through in the next part of your group theory. So continuing on with our next part of the group theory is this. It is a cyclic group. What is that, students? A cyclic group. A group that is like a cycle. Okay. So let's start reading. A group G is said to be a cyclic group if there exists an element B belonging to G. So there will exist an element B that will belong to G, okay, belong to G, such that every element of G is the power of B. Suppose I take an element X that belongs to G, it will be X to the power B. Every element of G is a power of B. Okay, let's rub that part which is guarding it. So let's write with a thinner one. Every element of G is a power of B. Then B is called the generator of G. So B is called the generator of G. Generator means not the generator that gives you electricity. Okay, generator means it generates the group. B generates the group. It's denoted this way. The generator is denoted in this way, and it is denoted as this way. So the order of a cyclic group is the same as that of the order of the generator B. That means the order of G is equal to the order of B. Okay, here is G is equal to the generator. Okay, then order of G is equal to order of B. So what did we understand from a cyclic group? A group G, there is a group G. It will be a cyclic group if there exists one element in that group. It will exist B. Okay, any element B, they have termed it as B. Okay, now it will not be B, it will be a number. Okay, an element will be a number, such that every element in that G set, every element in the G group, say element 1, element 2, element 3, every element, okay, every element of the G is of the power of B. So every element E1 to the power B, E2 to the power B, E3 to the power B, and so on. Okay, every element is to the power of B. Then that B is called the generator. Okay, because it generates the group. Okay, then it's called the generator, denoted by B. Okay, students. Now looking at this definition, you will not understand anything. So let me give you a mathematical proof. Okay, let's rub off whatever I have written here. More or less you have understood. How can we say, how are we going to get a generator for the cyclic group? Look at this. Let's take an example of, let me think of an example. What can I think of? Let's say I think of Z6. Okay, an example Z6 which has 0, 1, 2, 3, 4 and 5. This is a type of a cyclic group. I tell you, it is with addition modulo 6. Okay, now let's do this, then we'll understand. So we have 0, 1, 2, 3, 4 and 5. Addition modulo 6. 0, 1, 2, 3, 4 and 5. Okay, let's just make few lines from here also, so that we can split up the elements. Okay, let's just make few lines. I know I should have used grid boxes, but then if I use the grid boxes, the writing is going to get covered. Okay, so I'm not using grid boxes, rather I'm making the grids on my own. Okay, so let's just write the values. See how the G is getting covered up. So 0 plus 0, 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3, 4 and 5. 1, 2, 3, 3 plus 1, 4, then 1 plus 4, 5, and 1 plus 5 is C. Okay, next with 2, 2 zeros are 2, 2 plus 2 zeros are 2, no, 2 plus 0 is 2, 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, then 2 plus 4, 6, that means 0, then 5 plus 2, 7, that means 1. Okay, then 3 plus 0 is 3, then 3 plus 1 is 4, 3 plus 2, 5, 3 plus 3, 6, 0, 4, 5, 6, 7, 1, and of course here 2. Okay, then 4 plus 0 is 4, 4 plus 1, 5, okay, 4 plus 2, 6, 0, 4 plus 3, 7, that means 1, 4 plus 4, 8, 2, 4 plus 5, that is 9, that means you're supposed to get it 3. Okay, 5, then you have 5 plus 1 will give you 6, that will be 0, then you have 1 here, then 2, then of course 3 and 4. Okay, now look at this group. Look at this group very carefully. Let's say for 1, let's say with the generator 1, what are we getting? What can we generate with 1? With 1 we can generate more or less everything. 1, 2, 3, 4, 5, not 6, 0, right? 1, 2, 3, 4, 5 and 0. So this 1 is a generator, because 1 to the power 1 will give you 1, then 2 to the power 1 is going to give you 2, then 3 to the power 1 is going to give you 3, 4 to the power 1 is going to give you 4. So 1 is a generator. Let's do it 2. For 2, what can we generate? Of course 2, 4 and 0, right? We can generate that with 2. Alright, now let's move on to 3. What can we generate with 3? Of course you can generate 3 itself. Okay, 3. Then we can generate 0, because nothing to the power 3 is going to give you anything over here. Okay, then we start with a 4. With 4, what can we generate? We can generate 4 of course, and 0 also we can generate. Okay, and we can generate 2 also. Yes. Then 5, with 5, what else can we have? With 5, then 4, then 3, okay, then 2, then 1, and then 0. Okay, so we can generate this. This will be in like this curly brackets. Okay, so there you go. And with 0, what can we generate? Of course, with 0 we can only generate 0. Okay, so now if you look very carefully, you will find the generators. What are the generators? The generators are 1, the generators are 2, generators are 3, 4, 5 and 6. Every element is a generator. So then what does it say? Then B is called the generator of the group G. So here you can have 1 as the generator of the group, 2 as the generator of the group. Understanding, students? So that is basically about cyclic group. Okay, how some generator is generating the group, Okay, where G can be generated, you see over here G can be generated by, when you write G is equal to B equal to the generator, then over here G can be generated by 1, can't it? It can be generated by 1, right? So 1 is the generator over here, where you can find all the values being generated by 1. So that's it for this part or this video in group theory. You keep taking as much help as possible from Dr. Saurabh sir's classes, because all the help that you will be needing will be provided here at Saurabh sir's classes always. Alright, so thank you for watching this video. We shall continue with this in the next video. Bye bye students.